This is the Sun, our closest star in the universe. NASA's Solar Parker probe recently made its closest pass to our Sun. In this video, we will cover this whole incredible journey. Let's get started. Before discussing the probe, we will know more about our star. The Sun is a massive, glowing sphere of hot gas at the center of our solar system. We often use the phrase hotter than the surface of the Sun to describe extreme heat. Did you know that there is something in our solar system that is hotter than its surface? The Sun's surface temperature ranges from 6,200 degrees Celsius to 3,700 degrees Celsius. The Sun's outer atmosphere, called the corona, is significantly hotter compared to that. Although we don't have much understanding of corona yet, but this visualization will give you an idea. The boundary you see right now is corona, where the temperature ranges from 1 million to 2 million degrees, which is 150 times hotter than Sun's surface. It's one of the Sun's greatest mysteries, which still remains unsolved. This is where the Parker Solar Probe comes into the picture. In 1958, Dr. Eugene Parker published a groundbreaking paper proposing that the Sun continually emits a stream of charged particles, a phenomenon he called the solar wind. At the time, his idea was revolutionary and met with skepticism from many in the scientific community. However, Dr. Parker's theory was soon confirmed by observations, fundamentally changing our understanding of the Sun and its influence on the solar system. His work laid the foundation for modern heliophysics and space weather research. To honor his immense contributions, NASA named the spacecraft the Parker Solar Probe in 2017. This was the first time a NASA mission was named after a living person. At the age of 91, Dr. Parker witnessed the probe launch. The solar probe was launched, but getting to the Sun isn't as easy as just pointing a rocket at it and hitting it. You see, Earth is moving around the Sun at about 30 kilometers per second. That's around 7,000 miles per hour. Anything we launch from Earth starts with this sideways speed. To reach the Sun, the Parker Solar Probe must slow down significantly to drop closer to the Sun rather than orbit around it. Slowing down by that much requires more energy than any rocket could provide. So, how do we manage this? We are using Venus's gravity to slow down. After its launch on August 12, 2018, aboard the mighty Delta for Heavy rocket, the world's second most powerful rocket, the Parker Solar Probe set off not directly toward the Sun, but towards Venus. This might seem senseless. Here's the main part. The probe performs a series of 7 flybys of Venus over 7 years. Each time it swings by Venus, it uses the planet's gravity to reduce its speed and adjust its path closer to the Sun. This maneuver is called a gravity assist or a slingshot maneuver. By stealing a tiny bit of Venus's orbital energy, the probe slows down just enough to inch closer to the Sun without needing extra fuel. That's not all. As the Parker Solar Probe gets closer to the Sun, it also gains speed due to the Sun's immense gravitational pull. This causes the probe to reach incredible velocities, making it the fastest human-made object in history. During its closest approaches, known as perihelions, the probe goes over the speed of 430,000 miles per hour, about 700,000 kilometers per hour. To put that into perspective, you could travel from New York City to Tokyo in less than a minute. These record-breaking speeds are necessary for the probe to maintain its tight orbit around the Sun and to withstand the Sun's powerful gravity. After each Venus flyby, the Parker Solar Probe's orbit around the Sun becomes smaller, allowing it to get closer and closer. This carefully planned path isn't just efficient, it's essential. Without using Venus's gravity to slow down and adjust its orbit gradually, the probe would have needed an impractical amount of fuel to reach its destination. Since its journey began, the Parker Solar Probe has completed several gravity assists and close approaches. With each one, it breaks its records for speed and proximity to the Sun, traveling into regions never before explored. Navigating so close to the Sun isn't just about getting there, it's about surviving once you arrive. The probe has to withstand extreme heat and radiation, all while conducting groundbreaking scientific experiments. How do you build a spacecraft that can touch the Sun without melting? It sounds like an impossible challenge. It is possible. Solar probes survive the intense heat because of the extraordinary heat shield known as a thermal protection system. This heat shield was a giant protective umbrella keeping the spacecraft cool. Here's how it works. The heat shield comprises of carbon composite foam, which is sandwiched between two carbon plates. This shield is only for 0.5 inches thick, can withstand temperatures over 1,000 degrees Celsius on the side facing the Sun. Along with the shield is a reflective white coating designed explicitly for this mission. This coating prevents spacecraft from absorbing the heat, like a white t-shirt on a sunny day. The heat shield is connected to the spacecraft by a lightweight titanium truss, which is designed to minimize the heat from the shield to the spaceship. Behind the heat shield, the spacecraft is kept at a comfortable temperature of around 29 degrees Celsius. Even though the corona's temperature can reach over 1 million degrees Celsius, it's not as dangerous as it sounds because the particles are incredibly spread out. It's similar to putting your hand in a hot oven. You feel the heat, but your hand doesn't burn instantly because the air isn't dense. The lack of particles in space means less heat is transferred to the spacecraft, which means our probe can withstand it. This way, on December 24, 2024, the Solar Parker probe created history for its record-breaking closest approach to the Sun, breaking the previous record. The Parker Solar Probe flew just 3.8 million miles, which is around 6.1 million kilometers above the surface of the Sun. On board the probe is a memory card containing the names of over 1.1 million people who signed up to be part of this historic journey. It also includes a photo of Dr. Eugene Parker and a copy of his groundbreaking 1958 scientific paper predicting the existence of the solar wind. This means millions of us are touching the Sun, journeying alongside the spacecraft as it explores our star's mysteries. It's a reminder that space exploration is a collective human endeavor belonging to all of us. By touching the Sun, we're not just reaching for the stars, we're bringing their secrets back home to Earth. So the next time you feel the warmth of the Sun, remember there's a little spacecraft out there braving the solar inferno, all in the name of discovery. That's all with the Parker Solar Probe. Thanks for joining us on this incredible journey.